Hi everyone, welcome to this session. We are going to talk about native support of Prometheus monitoring in Apache Spark 3. My name is Dongjun Hyun. I'm an Apache Spark PMC member and committer, and also have been contributing to Apache Oak and Leap project. In Spark community, I'm focusing on Spark SQL and Kubernetes area. Then move to DB.
Thanks, Dongjun. I am a colleague of Dongjun. We work together on many interesting Spark projects. I am also a Spark PMC, System ML PMC, Unicorn committer, Bahi committer. But I'm not showing off my credential here, but I just want to show how much I love open source. I mostly work in Apache Spark project, but I'm also involved with other Apache projects to incubate them. In this talk, we want to go over monitoring in Spark. Note that many tech companies are using Spark to ETL, find a business insight from the data, or build some machine learning models to make billion-dollar decisions. You want Spark job running. You want to get the data or the model processed by Spark as fast as possible and also be accurate. Maybe it's less visible to end user, but really still important to you as a Spark developers, that you are running your Spark application efficiently and you are not wasting time and money under the hood of your systems. So there are a couple methods people use to monitor Spark job. Spark UI is probably the #1 method people use. Simply open HTTP IP address 4040 in the web browser, and you can see many useful information in real time while the job is running. You can see number of executor, memory usage, storage usage, and even execution plan for SQL query, job, stage, task metrics, and also garbage collection information will be shown. So please raise your hand if you have used Spark UI to debug your Spark job. 1, 2, 3, pretty much all of you. Okay, I'm joking here. It's pre-recorded, but my feeling is that everyone has used like Spark UI at some point. And you can also view those information after the job is finished by using a history server. And the other way people typically use is logging. So you can take a look at the event log or Spark process log after the fact, and then try to find useful information from the logs. However, the above method are mostly popular way to monitor and debug Spark job, but pretty much people use them when the job are starting failing or get paged by the downstream consumer saying that, oh, the pipeline is not running, the data is not being processed properly. And you can also argue that you can use Spark UI to do real-time monitoring, check out the real-time status, but no one's gonna watch Spark UI in real-time in production job. And also it's really hard to build an alerting system based on Spark UI. And at this time, the Spark jobs are failing for a while, and you need to start to dig into the history server or log to see what's going on and get the pipeline back to running again. So what if we have a monitoring system and alerting framework to proactively help us to prevent this kind of situation? So anyone who has run a complicated distributed system, we know that the system is always on a state of the partial degradation. And the challenge is that try to make the overall system look okay by proactively addressing degradation before catastrophic failure by monitoring the metrics in real time and get an alert to fix the underlying issues. There might be memory leak here, there, or some misconfiguration that cause some of the job running slower because the resource is not being utilized efficiently. Or maybe some of the interstate of the streaming job is going indefinitely. So Prometheus is the solution here. Prometheus is an open source decentralized monitoring tool. Literally, you can use for monitoring everything. Pretty much you can plug everything into that and monitor them. So the data model of Prometheus is multi-dimensional time series. And in many environments such as Kubernetes, it's really easy to deploy and operate it. It's use scalable and pool-based architectures. A new query engine language, NoSQL style, PostgreSQL, is designed to handle time series computation efficiently that can use to trigger alert. We like it a lot, and it's a great tool to monitor everything from the REST service, database, whatever you can imagine that can run in Kubernetes, including Apache Spark. The architecture of Prometheus is pull-based instead of push-based. Prometheus relies on service discovery in Kubernetes to find the running job and pull and scrape the metrics from the application endpoint. Since it's pull-based, you can set up multiple Prometheus instances for high availability. Even when you upgrade Prometheus, you can just do it without restarting the application. And the reason why Prometheus is not push-based is because sometimes it's really hard to know when you start a job submitted to a cluster, whether it's successfully started or not. Because if it's not started at all, you don't actually have the chance, to push out the notification, to push out the metrics to the Prometheus servers. Or it can be terminated at some point, and then there's no chance that you send out the metrics again. However, for some of the short-running jobs, the push model actually makes more sense. Since the job finished so quickly, and Prometheus may miss the time to scrape the metrics. As a result, Prometheus also provide a push gateway to support this kind of use case. Prometheus also have an alert manager that can take users' query expression written by PostgreSQL and then send out the alert accordingly. Prometheus Web UI is a really useful web interface that can be used to visualize the metrics. So in Spark 2.4, we have 3 ways to use Prometheus. So the first one is using JMX. Java is a management extension by enable Spark building JMXSink. Prometheus JMX exporter jar and its configuration file has to be added into your application jar. And then JMX exporter port has to be exposed, and Java agent option has to be added into the driver and executors. The downside of doing this is that it requires extra jar file, and also the deployment model has to be slightly changed. So the second way people can do is set up the Graphene server. So people can use Spark built-in JMXSink and then use Prometheus Graphene exporter to convert the metrics from Graphene metrics to Prometheus metrics. So this is good if you already have a Graphene environment set up in your production environment. However, if you don't have it, then it's gonna take extra couple steps to make this approach working. Finally, you can also use a push gateway approach. So basically the idea is that you can implement your own custom sink or use third-party library with Prometheus dependency to push metrics to a Prometheus server. And as we already talked about, push model is not really recommended unless it's a really short-running job. And typically for Spark job, it's not short-running, it's a long-running job. So it is not recommended. And also, this requires bring extra Prometheus job into your application as well. So the above approach has some pro and con. So the above approach are already used in production and stably, and it's a general approach that people can use Prometheus. However, the problem is that it's really difficult to set it up in new environment. And also some custom libraries has to be added into your Spark application, which people probably not prefer to do it. So in Spark 3.0, we want to make the experience much more smoother, and we want to be independent from other frameworks such as JMX or Graphene. And we don't want to introduce new dependency into user applications. And we also want to reuse the existing resource such as the current pod that has been used in Spark to monitor in the metrics. And we also want to take advantage of Prometheus Service Discovery in Kubernetes as much as possible so that Prometheus can find those running applications and pull the metrics from these Spark jobs. So I would like to introduce Dongjun, and he would be talking about more technical detail, how Spark 3 natively integrate with Prometheus. Thanks.
The first big change is usually a dependence change. As you see in this timeline, the Apache Spark has been using drop wizard metrics version 3 for a long time. Although it has been stable, the Apache Spark 3 upgraded it to version 4 in order to support Java 11. In general, we expect that user will see a stabler and comparable output. However, there are two notable side effects. The first, a drop wizard metric 4 inject additional label whose name is type. The adding a new label is considered as a breaking change in Prometheus monitoring, and you may need to add a relabeling configuration. The second, in case of gauge type, drop wizard also add duplicate metric like the example in the right bottom. This affects the existing Java agent way. You may increase the Prometheus server storage requirement. Spark 3 adds Executor MetricsSource. This is a new metric source providing a rich set of executor memory metrics. Not only JVM memory, but also the whole process tree, including Python daemon and other processes, are collected and categorized. The left box shows JVM metrics, and the right box shows process tree metrics. These metrics are collected from every executor to Spark driver by the heartbeat reporting. To support Prometheus monitoring more natively, Spark 3 adds a new MetricsSync tool. It's called Prometheus Sublet. You can enable it very easily by using metric.property file in Spark computation directory. There is no additional system requirement. Prometheus resource is another endpoint for all executor memory metrics. When the number of executors varies time to time, like a dynamic allocation situation, this provides the most efficient and convenient way to discover and collect all executor metrics, because Spark driver already have all information. The enabling Prometheus resource endpoint is easier than Prometheus Sublet. It's just one configuration, the spark.ui.prometheus.enable. Prometheus Sublet and Prometheus resource endpoints are disabled by default in Spark 3.0. It's because to prevent any accidental interference with existing metric collection pipeline. Spark 3 also add a new metric, spark_info, which follow a standard Prometheus way to expose Spark version and revision. This graph shows a Prometheus expression to monitor the number of Spark jobs per Spark version. And lastly, in Kubernetes environment, driver service annotation is also supported in Spark 3. It means that the Prometheus is able to discover the endpoint from Spark driver services. So far, I gave an overview of new features. Let's move on to the under the hood and see how to use this. Basically, the new endpoint of Prometheus service follow the metric sublet JSON endpoint style. JSON endpoint has been supported since the initial Spark release. You can find the JSON endpoint at /metrics/JSON. Prometheus endpoint is at /metrics/Prometheus by replacing JSON with Prometheus. The output result follow the existing output style of JMXSink plus JMX exporter plus Java agent way. This table summarizes the port number and endpoint in driver node and server worker and master. And this is one simple output example which you can get from Spark driver endpoint. So if you use Prometheus monitoring in Spark 2, you might be familiar with this. Like all the other metrics, metrics.property file is used to configure Prometheus servlet. This example configuration is already included in the built-in template. So you can enable this by simply copying the template file and uncommenting these Prometheus part. These 4 lines enable Prometheus servlet in Spark master node and worker node and driver. The Prometheus resource is also designed to provide the similar information from the existing JSON REST API. The new endpoint URL is /metric/executor and /Prometheus and exposed in driver side. When you enable Prometheus service, it's also recommended to enable process tree metrics. This is useful when you use PySpark. In this Spark shell example, both configurations are enabled, and you can get the executor metric from this new endpoint, like the result at the bottom. Okay, then, how can you monitor Spark jobs in Kubernetes cluster with these endpoints? There are some key monitoring use cases. The monitoring batch job memory behavior, dynamic allocation behavior, and streaming job behavior. These monitoring give us the answer for the following question. Is a job killed by whom? Or is there a risk to be killed in the near future? Is there any unexpected slowness due to resource competition or quarter limitation? Is the latency good enough? Let's start with batch job monitoring. What we need is only 4 configurations. One is spark.ui.prometheus.enable, as described so far, and the other 3 are just annotation to inform Prometheus to discover this endpoint. Prometheus expects these 3 annotations: scrape, path, port. You can give a proper value for Spark endpoint you want to expose. This is how to use Prometheus Service Discovery. If you install Prometheus with Helm, it works out of the box in this way. When you serve in the Spark job, it looks like this. The yellow part are the required configuration in the previous slide. This command launched the well-known Spark Py example, but this is designed to be killed by Kubernetes due to the lack of driver memory. Currently, it's only 2 GB. Let's see the Prometheus monitoring result. In this graph, each line shows 1 executor, including driver. The value is the sum of on-heap, off-heap, and direct pool memory. So we can see that the memory consumption of driver increased continuously and ended up with kill situation. With Prometheus alert manager, you can get notification before killed happen. Spark 3 support dynamic allocation in Kubernetes environment. This is very, very exciting improvement. For this example, I use 4 additional dynamic allocation configuration. That's all. The dynamic allocation enabled, executor idle timeout, then shuffle tracking enabled, and max executor. This job is using dynamic Python script, which repeat pi calculation twice. More specifically, this script compute pi value and sleep for 1 minute to shrink down to 0 executor status, and recompute pi value again. This is the previous monitoring result. We can see that the process task per minute for all executor. Each line is one executor. So we can see that dynamic allocation added new lines gradually in a stepwise manner and remove all of them during the idle time. For the second round pi calculation, it repeats the behavior again. Also, we can see that the tasks are evenly distributed across the executor. Spark driver now have two metric endpoints for Prometheus metric and Prometheus resource. To monitor both endpoints together, you can give driver path annotation and driver service annotation at the same time like this. The yellow paths are the new driver service annotation feature in Spark 3. From the driver metric, you can get the executor allocation ratio, which means the number of all executor over the number of target executor. These graphs show two jobs of previous dynamic Python script. In the first slide, all target executor are acquired. In the second job, less than 20% target executor are acquired. At the second job, the cluster might be very crowded at that time, or the user might set a wrong configuration for max executor without considering the given quarter limitation. Like I did here, I used 300 for max executor, but it was too big. Streaming job monitoring needs additional configuration. The spark.sql.streaming.metric enable. Then you can get 6 useful metrics: the latency, input rate, processing rate, state loss, and state byte, and event time watermark. This metric has a common prefix with metric namespace and query name part. So to track the metric consistently, it's highly recommended to set namespace and query name consistently from the beginning. All streaming metrics are important for alerting, but here are two typical monitoring conditions. The first, if the latency is greater than microbatch interval, it's a warning sign frequently. Spark can endure some situation, but the job needs to be redesigned to prevent future outages. Second, if the internal states grow indefinitely, it's also another warning sign. In Spark 2, sometimes a simple alias addition in SQL remove the watermark metadata completely. As a result, the internal states are not cleaned up properly. Then the job eventually dies. This is fixed in Spark 3.0. To use Prometheus monitoring in Kubernetes cluster, we recommend to use Prometheus Federation way and follow the principle of separation of concern. Every user namespace has a Prometheus server managed by its user. For example, namespace 1 collects only batch job monitoring metrics, while namespace 2 collects streaming job monitoring metrics. And the cluster-wise Prometheus server only monitor a subset of metrics like spark_info. So limitation and tips. Please note that new endpoints of Spark 3 are still experimental. New endpoints expose only Spark metric, starting with metric underscore or Spark info. The previous Java agent method can expose more metric like JVM info, including Java version. Previous servlet does not follow Prometheus naming convention. Instead, it's designed to follow Spark 2 naming convention for consistency in Spark version. And also, I mentioned before, the number of metric grows by default if we don't set the configuration properly. Then summary, Spark 3 provides a better integration with Prometheus monitoring, especially in Kubernetes environment. The metric collection becomes much easier than Spark 2. New Prometheus-style endpoints are independent and additional option, so there is no additional requirement, and user can migrate into these new endpoints or use them with the existing method in a mixed way. Thank you.